Hello student, I am Dr. S. L. Munde, Assistant Professor and NSS Program Officer, Department of Mathematics 3, RLT College of Science, Akola. Dear student, in previous lecture we have completed Fourier transform unit. So today we will start unit number 3 and unit number 3 is Fourier series. In this lecture, we will see some of the introduction and some basic definitions that are required for the Fourier series. Okay, so first we will see some basic definitions of the Fourier series for the Fourier series. So first definition is a periodic function. So this periodic function is totally depends on the concept of the periodic function is used in a Fourier series because Fourier series is totally depends on a period. Okay, that is on a periodic function. Okay, so what do you mean by periodic function? Okay, so first we will see the definition of the periodic function. So let us suppose that f of x is any function if the value of each ordinate f of x repeated itself at equal interval in the abscissa, then f of x is said to be a periodic function. That means if the value of f of x is repeated on a some interval, on a given some interval, then that f of x function is called as a periodic function. That means the value of the f of x function is repeat again and again in a particular period. So that period that function is called as a periodic function. Okay, so for example, f of x, so f of x plus t, f of x plus 2t, so t is a period. Okay, so here f of x, so this is again repeat f of x plus t equal to f of x plus 2t, and next is f of x plus 3t. Okay, so then f of x is said to be a periodic function. Okay, and here t is called as the period of the function f of x because here t is a repeated again and again. So therefore that function this function is called as a periodic function. Okay, so for example, sin x, cos x, sec x and cosec x are the periodic function of the period 2 pi. Okay, so if you see the curve of the graph of the sin x, cos x, sec x and cosec x, which is lies between 0 to 2 pi. Okay, that is the period of the that is 2 pi. Okay, and then second example, that is tan x and cot x are the periodic function with the period is pi. Okay, so this function has a period pi and this function has a period 2 pi, because means we can say that this sin x, cos x, sec x and cosec x repeat after the period 2 pi. Okay, so this repeat after the pi. Okay, so this is the periodic function definition. Then we will see the even and odd function, because even and odd function is a very most important role in a Fourier series. Okay, when we say that the given function is a even function. Okay, so if the value of the f of x, f of minus x equal to f of x, okay, a function f of x is said to be an even function if f of minus x equal to f of x. Okay, so suppose that we have given any function that is f of x, if you replace x instead of minus x, so if you get the repeat the function that is f of x, the graph of then that function is called as a even function. Okay, the graph of the even function is symmetrical about the y-axis. Okay, so for example, x square, cos x, sin square x are the even function. Okay, so if you solve the problems, if you put x equal to x, so here, so you will get the f of x square, so you will get the cos x, so you will get the sin square x. Okay, so these are the example of the even function. Then we will see the which are the odd function. What is the odd function? Okay, so what is the odd function? Okay, a function f of x is said to be odd function when if f of minus x equal to minus f of x, if the f of minus x which gives the value which is equal to minus f of x, then that function is called as a odd function. the graph of the odd function is symmetrical about the origin. Okay, so for example, x cube, sin x, sin cube x are the odd functions. So these are the example of the odd function. Now we see the some basic concept of the odd and even function. The product of the two even functions or two odd function is always even function. So here you have to remember this note. The product of the two even function and product of the two odd function is always even function. Okay. Second is the product of the even function and odd function. The product of the even function and odd function is always odd function. Is always odd function. So these are the two statement, very important. Okay. Now we will see the what is the role of odd function and even function in a integration. Okay, so if the f of x is an even function, then the integral minus a to plus a f of x dx. Okay, so this may be the minus infinity to plus infinity, minus a to minus a to plus a. Okay, so here lower limit and upper limit will be same. Okay, but only change is minus and plus. Okay, okay. So f of x is an even function, then the integral minus a to plus a f of x dx can be written as 2 times integral 0 to a f of x dx. Okay, and f of x is an odd function, then this integral can be written as integral minus a to f of x dx equal to 0. ठीक आहे, तर या ठिकाणी आपल्याला ऑड फंक्शन आणि इवन फंक्शन इंटिग्रेशनच्या फॉर्ममध्ये लिहायचं जर असेल, ओके, तर याप्रमाणे आपण या ठिकाणी लिहू शकणार आहे. जर एफ ऑफ एक्स जर ऑड इवन फंक्शन जर असेल तर इंटिग्रेशन ऑफ मायनस ए टू ए एफ ऑफ एक्स डी एक्स इज रिटन ॲज 2 टाइम्स इंटिग्रल 0 टू ए एफ ऑफ एक्स डी एक्स. या ठिकाणी मायनस ए टू ए आहे, ते इंटिग्रेशन या ठिकाणी चेंज होणार आहे आणि लिमिट सुद्धा पण या ठिकाणी चेंज होणार आहे. सो 2 टाइम्स 0 टू ए एफ ऑफ एक्स डी एक्स. ठीक आहे. जर फंक्शन एफ ऑफ एक्स हे ऑड फंक्शन जर असेल तर इंटिग्रेशन ऑफ मायनस ए टू एफ ऑफ एक्स डी एक्स या इंटिग्रेशनची व्हॅल्यू तुम्हाला 0 मिळेल. ठीक आहे. सो दिस इज द व्हेरी important concept to solve the Fourier series problem. Now we will see the what is the Fourier series. What is the Fourier series? Okay, so the Fourier series are associated with the periodic function defined on a some interval I. Okay, I already told you Fourier series totally associated with the periodic function and which is defined on a some interval I, and this Fourier series is defined in a some interval I. So that interval may be the plus a to minus a. Okay, so in general the intervals concerned are of type. In generally in Fourier series the interval will be lies 0 to 2 pi, minus pi to pi, minus l to l. ठीक आहे. जनरली Fourier series मध्ये intervals 0 to 2 pi राहणार आहे, minus pi to pi राहणार आहे, minus l to l राहणार आहे. So these are the boundary points. Okay, or we can say the interval. All these intervals are accommodated in I. Okay, I means interval. I could c comma c plus 12. So this is the general term. Interval that is c plus 2l. Okay, so this is 2l is the period. Okay, so if c equal to 0, then this interval will becomes 0 to 2 pi. If c equal to minus pi, then this interval will becomes minus pi to pi. If c equal to minus l, then this interval will becomes minus l to plus l. So these are the some intervals which we will use in Fourier series. Okay, so therefore for general consideration, assume that f of x is a periodic function of a period 2l and is defined on interval I, and that interval will be c plus 2l of length 2l. So this is the length of the interval. How will you find out the length of the interval? That is b minus a. B means this term and a means this term. B minus a means c plus twice l minus c. So c will get here. So you will get the that is l. So this is the length of the interval, that is twice l. Okay. Now we will see the proper definition of the Fourier series. What is the proper definition of the Fourier series? The Fourier series associated with the 2L periodic function associated with the uh, 2L periodic function f of x is the trigonometric function. So here f of x, the value of f of x is which is the which gives the trigonometric series which contains sin x, sin and cos series. Okay, so this can be written as Fourier series f of x equal to a0. So this can be written as f of x, f of x. So this can be written as f of x, f of x equal to a0 plus summation n equal to 1 to infinity an cos n pi x upon capital L plus bn sin n pi x upon capital L. Okay, so this is the Fourier series formula, general Fourier series formula. So here a0, an and bn are the coefficients of the Fourier series, and it is given by the Euler's formula, that is a0 equal to 1 upon 2 capital L integral c to c plus twice L f of x dx. An is 1 upon capital L integral c to c plus twice L f of x cos n pi x upon L dx, where n equal to 1 to 3 and so on. Bn equal to 1 upon capital L integral c plus twice L f of x sin n pi x upon L dx, n equal to 1 to 3 and so on. So here the numbers a0, a1, a2, a3 and b1, b1, b2, b3 are called as the Fourier coefficients. Okay, so this is the definition of the Fourier series, and these are the Fourier coefficients. Okay, so generally we can say that the Fourier series is which contains trigonometric terms, that is cos x, cos and sine. Okay, and this can be written in this equation number 1. Okay, so now we will see the determination of the Fourier coefficients Euler formula. We have already seen in definition. Okay, for the interval twice L, period twice L. Okay, so here we will see, let f of x be the periodic function of the period 2 pi. Okay, so here we will see the period for the 2 pi, which can be represented in the interval c plus 2 pi. So this is the interval, and which is given as f of x a0 plus summation n equal to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Okay, if the period is 2 pi, then the Fourier series can be defined as in this way. Okay, here cos nx, here sin nx. Okay, so here is a different type because this is the period of 2l. Okay, so here cos n pi x upon l, sin n pi x. So here a difference is only cos nx and here sin nx. Okay, so these are the some calculations part. After solving this equation integration and taking separate part, we get a0 equal to 1 upon 2 pi integral over c plus 2 pi f of x dx. So this is the value of the a0, coefficient of the Fourier series. Then another is an, the value of an 1 upon pi integral c plus 2 pi f of x cos nx dx. And third is bn, that is 1 upon pi integral c plus 2 pi f of x sin nx dx. Okay, so these three formulas are very important. So this first formula is very important, and this second, and this third, and this fourth. Okay, so these are the fourth formulae if the period is 2 pi. Okay, so this is a very most important formula for the determination of the Fourier coefficients in interval c to c plus 2 pi. Okay, so this is the period of 2 pi. Okay, now this all can be written as, if the Fourier series in a period of 2 pi, the first coefficient is a0 equal to 1 upon 2 pi integral c to c plus 2 pi f of x dx, and second is an 1 upon pi integral c to c plus 2 pi f of x cos nx, and third is bn 1 upon pi integral c plus 2 pi f of x sin nx dx. So these three formulae are the used in when the period is given as a 2 pi. Okay. Now we will see some cases. In above definition, if we put c equal to 0, then above interval will become 0 to 2 pi. Then the Fourier series of f of x is given by, okay, in above definition, so this is the interval for c plus 2 pi. If c equal to 0, so then this interval will become 0 to 2 pi. So case number 1, if c equal to 0, then interval will become 0 to 2 pi. Then the Fourier series is given as f of x equal to a0 plus n summation n equal to 1 to infinity a n cos nx dx plus summation n equal to 1 to infinity bn sin nx dx. So where a0 is 1 upon 2 pi integral 0 to 2 pi f of x dx, a0, then an is 1 upon pi integral 0 to 2 pi f of x cos nx dx, and bn is 1 upon pi integral 0 to 2 pi f of x sin nx dx. So these three formulae are called as a Fourier coefficients of the Fourier series in interval 0 to 2 pi. Second case number 2, if c equal to minus pi, then above interval will becomes minus pi to pi. Then the Fourier series f of x is given as f of x equal to a0 plus summation n equal to 1 to infinity a n cos nx dx plus summation n equal to 1 to infinity bn sin x dx. Okay, so where a0 and an and bn are given in this way, that is a0 equal to 1 upon pi 2 pi minus pi to pi f of x dx, an equal to 1 upon pi integral minus pi to pi f of x cos nx dx, and bn equal to 1 upon pi integral minus pi to pi f of x sin nx dx. Okay, so these are the Fourier coefficients when the interval is given is minus pi to pi. Okay, now we will see the even function and odd function in a Fourier series. What are the role of the even function and odd function in a Fourier series? Even function for the interval minus pi to pi. If f of x is a even function in an interval minus pi to pi, then the coefficients are becomes a0 equal to 1 upon 2 pi minus pi to pi f of x dx. Okay, so here f of x is a even function. Then by using the odd and even function definition, so this interval can be written as 2 times 0 to pi, 0 to 2 pi. So therefore 1 upon 2 pi is as it is, and the conversion of this interval is 2 times 0 to pi f of x dx, because f of x is a even function. Okay. Second, an equal to 1 upon pi integral minus pi to pi f of x cos nx dx. So here f of x is a even function, and we know that the cos nx is also even function. Okay, then we know that the product of the even function is always a even function. So therefore by using the definition of the even function, so this can be written as 2 times 1 upon pi 2 times 0 to pi f of x cos nx dx. Okay. Third, bn 1 upon pi minus pi to pi f of x sin x. So here f of x is a even function and sin nx is a odd function. Okay, then the product of the even and odd function is always a odd function. So therefore by the using the definition of the odd function, the value of the this integral minus pi to pi f of x dx, this will become 0. So therefore bn equal to 0. Okay. Second, odd function in a minus pi to pi. So let us suppose that f of x is an odd function in an interval minus pi to pi. Then the coefficient a0 equal to 1 upon 2 pi integral minus pi to pi f of x dx. So here f of x is an odd function, therefore the value of this integral will become 0. Then an 1 upon pi integral minus pi to pi f of x cos nx dx. F of x is an odd function, cos that is an even function. So product of the cos and even function will become the odd function, and the integration of the value of the integration odd function is 0. So therefore 1 upon pi minus pi to pi odd function, that is 0. Bn 1 upon pi minus pi to pi f of x sin nx. So here f of x is an odd function and sin nx is also odd function. The product of the odd function is always a even function. The product of the odd function is always a even function. Okay, so this integral can be written as 1 upon pi 2 times 0 to pi f of x sin nx dx. Okay, so the Fourier series, thus if f of x is even in minus pi to pi, in short we will write if f of x is even in minus pi to pi, then a0 will be 1 upon pi, so this 2 pi will get cancelled, 1 upon pi 0 to pi f of x dx. An is 2 upon pi 0 to pi f of x cos nx dx, and bn is 0. Okay, so this is 1 upon pi. Okay, sorry, 2 times. Okay, this is 2 times. Then if f of x is order function in interval minus pi to pi, then we will get a0 equal to 0, an equal to 0, and bn is 2 upon pi integral 0 to pi f of x sin nx dx. Okay, so these are the some basic concept of the Fourier series. So these are the very important formulas and definitions of which required to solve the problems on a Fourier series. So in next lecture we will see again some problems, or we can say there's some basic formulas that we will use to solve the Fourier series problem.